We are live. You can start.
Okay, thank you, Chike. Good evening, everybody. My name is Orinda Mola, and um, this evening we'll be discussing solidity, memory, and storage. So let's dive right into it. So the table of contents, solidity, memory, and storage. Memory and solidity, and also the storage. And we'll be discussing variable storage allocation, fixed size variables, and dynamic size variables, and also the takeaways from the whole content. Okay, so next, okay, so solidity, storage, and memory. In solidity, storage and memory are keywords to describe storage allocation. So memory in solidity is similar to RAM, a temporary location to store data, while storage is similar to hard disk. It holds data to be used anywhere in the program. And so Solidity smart contract take any amount of memory during execution, but once the execution stops, the memory is completely deleted while the storage stays persistent. So what this is telling us is that memory uh, memory temporarily stores data um, in functions, definitely in functions in particular, but while storage stores data, and this data can be used all through the code. So memory in Solidity, as said earlier, memory is a keyword that is used to store data temporarily for function execution in a contract, like I said earlier. And the data is stored temporarily during execution and gets wiped completely once function is executed. Examples are function arguments, variable declaration declared in functions. Memory memory can only be newly created in a function by creating an instance of variable types like array, struct, or copied from a storage reference variable. What this sentence is trying to say is that um, memory variables can be a reference of storage variables like array. It could be any variable type, and memory has less gas consumption. And this is because once the function is executed, the data get wiped and it doesn't consume gas. Um, and better for intermediate calculation, like let's say for calculations you need within the functions. So once the calculations is done, then it's done and it gets deleted. So that is what the memory in Solidity is. Um, so next, storage in Solidity. Storage is also a keyword in Solidity that is used to describe data that have permanently stored. Um, the data in storage area is accessible sorry, there's a typo here, to the smart contract function. The data does not get deleted. The data does not get deleted. State variables are storage data, also like array and struct. And the storage data cannot be newly created in function. So what this sentence is saying is that unlike memory where you can create new variables like a reference, probably a new variable within the function, you cannot create uh, a new storage variable in function. So storage data cannot be newly created in functions like the memory storage. Yes, storage data, I mean, like state variables referenced in functions are usually called pre-allocated data in the contract storage. So they are already allocated in the contract storage, then you can reference them in functions. So storage data consumes more gas, which is because it is permanently stored in the smart contract. Okay, so variable allocation, variable storage allocation. So Solidity stores variable in slots, which can take only up to 256 bits, that is 32 bytes, not less. If it exceeds the variable, will pass to a new slot. Variables are in order of lower order, that is from left to right, starting from 0. So for fixed size variables, so struct and array are stored differently. They create new slots. The elements are put into the slot depending on the size of the variable. Then also fixed size array creates new slots. The elements are put into the slot depending on the size of the variable also. So if the size of the variable exceeds, the remaining size gets new slots. So struct and array are stored differently, like I said. So let's quickly check out this tool to explain the fixed size variable. Sorry. Okay, so let's check out the contract in line 6. So like I said, each slot can only take up to 256 bits, right? And we have in line 8, we have UIN 256, which will be in slot 0. And also line line 9, which is an array that has two elements. So this variable has two elements, and they take the next slot. They take slots 1 and sorry, please hold on for me. Yeah, so B occupies the new slot 1, which contains 2 elements because the data type of B is UIN 256. So the next slot is 2, which will be the next element, which will be the second element of B. Then struct entries are just declared, so it doesn't really count. So now in line 14, we can see that our struct has 2 properties. Our struct student has 2 properties, which are going to take the slot 3 and 4. So like I said in the explanation here, the elements are put in the slot depending on the size of the variable. Fixed size array creates new slots. The elements are put into slot depending on the size of the variable. So that brings us to the next contract again. So another example here is explaining how variable of different bits are stored. So now in line 22, we have UINT A, UINT 8, right? Not UINT, not 256 this time around, which is stored in slot 0. Then the next UINT is UINT 16, which is B, which also gets stored in slot 0. Unlike the previous storage contract that we have, where we have 1 slot for 1 variable. So for the address, address is I think address has about 40 hexadecimal character, yes. So it's 160 bits, not 256. So it also gets stored. So there's still space in slot 0 that address can still fit in. Then also for the bool. So bool is a type, and like we know, right? it only needs 1 bit to store. So the smallest data type is 8 bits in Solidity, right? And bool will also be able to fit in the slot 0. So line 26, we have doing C, which is sorry, we have variable C, which is 64 bits also, which also still can fit into slot 0. So from line 22 to 26, if we calculate the bit size, we have 256. It equals 256. So that brings us to line 27, where we have another 256 bits that takes the next slot, which is 0, which is 1 rather, which is 1. Then it gets filled up. There's no more space. Then line 28, which is another unit 8, will take the next slot, which is 2. Then we have the unit 256, will take the next slot, which is 3. And this is because of what I said earlier, that if the size exceeds the if the size exceeds 256, it's the variable jumps to the next slot to get fixed in. So yes, that is for the fixed size variables. So for the dynamic size variable, so dynamic size array creates a new slot. This slot only stores the length of the array, while the value in the array will be stored in another location. So mapping also creates a new slot like array. And also for bytes and strings. So byte and strings types are seen as dynamic array too, meaning that they can store arbitrary data size. Each element of a variable of type byte is a single byte, right? So they are arbitrary, they are really large. So each element of a variable of type string is a character of the string. So now let's go back to our code to explain that. Okay, so for dynamic variables, it's a complex, it's complex to explain because it has to do with, you need to have a good knowledge of hexadecimals and byte and bit and stuff like that. So now our contract storage B. So in line 37, we have Win 256, right? We have Win 256, which is A. Get the slot 0. And next we have fixed. Yes, we have fixed. We have fixed variable B, which also has. So let's assume that this line 38 is a dynamic. Let me remove the 3. Okay, so let's assume that this variable is a dynamic variable, right? And we probably in our smart contract later, we keep adding, items to this dynamic size variable, this dynamic size array. So it gets each slot for each item, like I explained earlier here in our contract, in our first contract, in line 9, it gets slots 1 and 2. So that is how it is for the dynamic array also. So it keeps getting the next slot. It doesn't get fixed into one slot like we have in our second contract rather. So likewise for the struct too, we have 2 items here too, and they get the next slot 4 and 5.
Please, can you zoom in?
Zoom in.
Yes.
Okay. I'm sorry. Is it better? Is it better?
Yes. Yes. Thank
Okay.
you.
Okay. All right. So also not to confuse because then sometimes when you create your when you have your smart contracts, you want to indicate where you use the keyword storage and memory. So for this contract storage 4, we have array of strings, right, which we call item. So let's say, for instance, and it's actually dynamic, right? Because we don't have any fixed amount of we don't have any fixed number of strings that can go into it, so it's dynamic. So let's say you push a first item, which takes the slot 0, and then you push the second item, which takes the next slot. Then you want to create, you want to okay, so you want to create a new items, which because you want to check the items which you want to create new items and modify. You want to create new items to modify what you already have in your items array, right? So, and initially you have apple and orange, and then you want to change the item one, the first item. I'm sorry, the second item. Array starts from index 0. So you want to change the second item, then you have to indicate storage because it's like a pointer to where your variable is stored, right? So you have to point to where the variables are stored. Then you use the keyword storage to point there, and then you change the value you want to change. So this line 57 is going to change line 56 to lemon, since you're already pointing to the storage. So next is another example. Okay, so next is another example where we use memory in our function. So like I said, you need to be careful of what you use in your functions, because you don't want to just manipulate, you don't want to just modify your state variables. You really want your functions to, have the have their variable and get executed within the functions. So yeah, in line 74, you have function change first element, string, memory item, new items, and you want to assign lemon to item 0 to the first item within this function. So this line 74 is telling you that you are reading from the memory. You are actually like creating like an instance of new item as a memory. Then you are changing the first item here, which is initially apple in line 68. So you are changing it within this function. So once this function is executed, you still have your apple as the first item and not lemon. But in this function, you have your first item, which takes the slot 0, which is the first item, as lemon. That is only within the function. It doesn't affect the state variable like we did here, like we did in our storage 4 contracts. Here we are pointing to the storage, but here we are pointing to an instance of the array, not the storage. So you are pointing to the instance of the array here to make the changes within the function, and once it gets executed, it's gone. You still have your state variables the way they are. So yes, I will need to kind of zoom out a bit here. Oh, sorry, Martin is still zooming. Okay, so for struct, when you want to, I believe we all understand how struct works. It's like a template for our for how should I put it? Yes, it's like a template where we have different properties for our variable. Yeah, let me use the word variable. So like a template where we have different properties for our variable. So let's say struct players, we have the property ID and scores, right? And then you want to create a new player. There we have the function create players, which has parameters of ID and scores also. And then you want to create a new player. But of course, you need to have like an instance of, you need to have the instance of the player in your function. So when you are creating a new, unless you need the function temporarily in your function, I'm sorry, just if, okay, only if you need the new player temporarily in your function, right? Only if you need the new player temporarily in your function, that is when you can make this keyword here. I'm sure some of us would have come across it. You can only make the keyword here memory. But if you are creating a new player, to have their details, you need to indicate that you are pointing to the storage. You are pointing to the storage and not the memory. Let me take that again. So you have the template of, you have the characteristics of the player you want to create, the ID and the scores, and then you want to create a new player. So definitely you don't want to create the new player and then after creating the new player, it gets deleted, right? You want it to be stored, right? So that is when you call this player as a type. You call this struct player as a type here in line 97. You call it as a type, yes. And then you indicate that you are actually interacting with the storage to create a new player, which we have the mapping and the players linked together. We have the mapping and the player linked together too. I think this is another topic entirely, but I'm just here to I'm only explaining the storage and memory. So yeah, you are creating a new player because you are creating a new player using the keyword storage because they are interacting with the storage. So let's check what next here. Okay. Okay, so bytes and string types are seen as dynamic array. Yes, I explained that. Meaning they can store arbitrary data size. Each element of variable of types bytes is a single byte, and each element of the variable of type string is the character of the string. So the key takeaways from here is memory stores data temporarily for functional execution, while storage holds data in the storage. And also memories can only be created newly in a function. Yes, memories can only be newly created in a function, while storage cannot be newly created in a function. Then lastly, memory consumes less gas, while storage consumes more gas. So going back to our code, sorry. So going back to our code, there are different instances where you see the keyword memory and storage, and I'll be providing more resources and I'll be available to answer any questions around memory and storage, both on Discord and I think right now, if there's any question. Rose, Chikere, do you have any question?
Bollywood's fair is here, so I think he can
Yeah,
read out the
there's just one
question.
question so far. I think
What?
you've actually answered it. The question was, when do we know when to use memory and storage in our code?
Okay, so let me just quickly take that again. So um, you need to know when you need to know when you need to. Sorry, can you take the question again?
He said, when do we know when to use memory and storage in our code? Like, how do they know
Okay,
when to use memory and storage?
when to use storage memory. Okay, so when you use storage is when you're actually interacting with state variables. Um, Generally, state variables are stored in the storage are storage data, right? And memories are function data. So when you want to interact with the storage, which is the blockchain, let's for example, as the blockchain, you use the keyword storage. And when you want to just create like a temporary say variable, or you need to reference the state variable, then you use memory. That is when your data are based on memory. So using the keywords, memories are used in the functions, and also storage can be used in the function. That is if you are sure that you really want to interact with the storage. So I hope that answers the question. Does that answer the question?
Well, I hope it does. I think he explains it very well. So if it does not, I think you should ask again. But there's no other questions for now.
Okay. But if there are any more questions, I think we can take them on this topic. So Chikere,
I'm here.
yeah, I guess we done.
Someone said that he has a question, but he has not posted the question.
Okay, let's
Okay,
read
so
them. Let's see.
there's another question. I actually don't know what the question means, but it's
Okay.
she said, where does storage point to?
But story point, basically the story points to the blockchain where the data are being stored.
Okay. So there's another question also. Is the byte type dynamic? I thought one must specify a size.
Yes, you can specify. That is why um you need to be careful the size of bytes you use, right? If you know the value your variable is taking will not um is not large, then you need to bring the bytes down. But generally, everybody just use, UNT256, and which actually consumes the storage.
So there's another question now. It says,
Okay.
in the body of code you have here,
Okay.
there is a number of lines that indicate an error. This
Oh,
statement during my task 5. How do you sort out those errors that keep getting highlighted as code?
oh, okay. So basically, it's not a full functioning. They are not full functioning codes. I just like wrote something small to explain in examples. Okay. How do they solve the errors, right?
Yes.
Yes, of course. You go to the warnings and you read what the error is about. Then, if it's not clear, you try to Google, and I'm sure you have tons of people that have the same error and can easily get your errors fixed. I hope that answers it. So these are just friendly warnings because the codes are not fully functioning. So I just wrote them to explain an example. So they are not like typical errors that will not make your code not deploy. That's why I call them friendly errors. friendly one, brother. So you can easily just Google if you have any error, and I'm sure you have tons of people that have had the same issues, and their solution will be your solution. So any other question?
I think that's about all.
Okay. So Chikere, do we wait a bit or if there will be any other question?
Let me check. Someone, there's actually just okay. Someone asked another question. Said, do we have a maximum number of slots a contract can have?
Not okay. Well, generally the maximum size of a contract is 24 KB. So you need to be very careful of how you use your storage. So and then I can always provide resources that explains better on how to manage your storage. The person can ask a question on this so that I can provide more resources on that. But the maximum size of a smart contract is 24 KB.
So someone said, can we do all you did here on Truffle and add that also?
All I did as well.
I don't know the code, I suppose.
Okay. Well, yes, okay. I will fix the errors and make the examples more functioning. So I will share the codes with everybody on Discord. So the person should please tag me on Discord so that I can post the code better.
Okay.
Yeah.
Okay, I guess that will be all. Thank you so much, everybody, for coming to today's class. Thank you so much, Oni. Thank you so much, Boliwatufe. Good night.
All right. Good night, everybody. Thank you very much, Boluwatufe. Thank you, Chikiri, and everybody that comes to call.
Yeah. Good night, guys.
All right. Yeah. Bye.
Before I go, Oni Damola, they're asking you for your name. Okay, her name is Oni Damola. Just in case, Sha.
Bolu. Bolu, calm down.